Hello everyone and welcome. In this episode, we will set up Kubernetes cluster on a couple of Ubuntu servers without installing Docker. I've already created a video setting up a multi-node Kubernetes cluster on CentOS. However, since the recording of that video, they're having a couple of new important developments. The first one is Red Hat announced late last year that CentOS will no longer be supported beyond 2021. So which means end of this year, CentOS 8 will be the last version of supported CentOS. Unfortunately, they kind of changed their mind because it was supposed to be supported until 2029, but once, I guess, IBM took over, the grid also took over the corporation, and they don't want to spend any resources on the free version of Red Hat Enterprise, which is CentOS. So that will be deprecated. If you are on CentOS 7, however, it is still supported until 2024. There is another kind of version of CentOS going forward. It's called CentOS Stream. But that is really a dev branch for enterprise, for Red Hat Enterprise. So I wouldn't recommend using that for production environment, but for development, that's fine. If you don't mind frequent updates that may break your workload, then go ahead and you want to just play with it. However, for serious production, I wouldn't recommend the Stream version of CentOS. So I guess that's it. So we need to get off CentOS 8 as soon as possible. And the other announcement from Google was that Docker runtime support will be deprecated in version 1.22, which is slated to be released later this year. And this is a direct quote from Kubernetes side, and they say, when Docker runtime support is removed in a future release, in parentheses, currently planned for the 1.2.2 release in late 2021 of Kubernetes, it will no longer be supported, and you will need to switch to one of the other compliant container runtimes, like Containerd or CRIO. So again, this is a direct quote from the Kubernetes page. I just want to make one thing clear here. We are talking about a Docker runtime that runs inside Kubernetes. We are not talking about the Docker on the client where you create your containers. That's not going to change. You still have to use Docker. It's the best tool right now to create the packages, to create the containers that will be deployed to Kubernetes. So we're not talking about that. We're talking about only once you deploy your container to the Kubernetes environment, Kubernetes behind the scene is no longer will be using the Docker runtime. So we need to get off of that as well. So this is the motivation for me to create this new video. So the big question is why Kubernetes is dropping Docker runtime. So a little bit of kind of history. When Kubernetes was created, Docker was really the only game in town for managing the images, and that's the support for Kubernetes was built directly and deeply into Kubernetes. Then other container management systems such as RKTNet and others started coming to the market, and then Google kind of realized that having to recompile every time that a new container management system is released is not going to be practical. So in version 1.5 of Kubernetes, Google introduced Container Runtime Interface, or CRI. It is a plugin interface which enables a kubelet to use a wide variety of containers. So we are not really tied to Docker or any other runtime, for that purpose, and you can switch container runtime as the new ones come along, without the need to kind of recompile for Google to compile Kubernetes every time that a new runtime management is released. So this is the high-level architecture of CRI. So CRI is, or Container Runtime Interface, is implemented as a client-server architecture. So we have kubelet that talks to CRI through gRPC. So there's a gRPC server. So this piece, which is a CRI runtime API, is actually a gRPC server. And kubelet talks to that through a gRPC client piece. And inside that, there are a couple of important services. One is CRI image service, which basically pulls the images and manages services from the container runtime. So containers coming through managed by CRI image service. The other one is CRI runtime service, basically manages the runtime of the containers and pods. When you create a new pod or a container, and that's that manages through the CRI. Also, when you talk directly to a container, a pod, that is, for instance, you SH into a pod, those calls are going through the CRI runtime. CRI runtime also talks to CNI client. So CNI stands for Container Network Interface. And the CNI, then CNI client talks to the CNI provider, such as Calico or Flannel. And those containers manage the networking part of the containers and pods. For instance, creating the network namespaces inside the containers and also managing the IP addresses. So I have a full course on CNI, actually 3 courses on. So if you want to know more about CNI and how that works, I'll put this link to those courses that you can take. And also then there's a provider client that basically talks to container runtime. And container runtime is really manages the containers. And right now there are a number of containers such as runtime such as Container D and CRIO that are supported. So you might be asking, so where does actually Docker fits into in this architecture? And actually it doesn't. So right now, in order to support Docker, Google has created Kubernetes team has created what is called a Docker shim. So because it's not CRI compatible, that actually has to go a different route. And this kind of works the same way as CRI. It talks to Docker, and then inside Docker, as you can see, Docker itself uses Container D. So, but the container is not directly accessible because Docker is not CRI compliant. So that's why it has to go through this shim. So going forward, they say we are not going to support this model anymore because Container D, we can directly support that and we can talk to it directly. Why do we have to go through Docker? So going forward, Docker runtime, again, we are not talking about the client, we are talking about the runtime Docker will no longer be supported. So hopefully that makes sense. And next we are going to actually go in the command line and start installing Kubernetes and actually Containerd first, and then Kubernetes follow that. We are inside Visual Studio Code, and that's what I'll be using to run the necessary scripts to set up our cluster. I'll be using 2 servers. These are the IP addresses. This will be designated as the master and the other one as just a regular node. You can, of course, add as many nodes as you wish, but for simplicity, I just add 2 for this demo. I have provided a link to this script so you can go ahead and install it yourself. And so I have also provided comments on where to run each script. So this section of the script needs to be run on all nodes, regardless of being a master or just a regular node. And the first thing that you need to do on line 9 and 10, and we need to make sure that our server is up to date. It's got the latest patches installed. So those are the two commands that you need to run on your Ubuntu server. Next, on line 13 is the line that actually we are going to install containerd. So again, to remind you, containerd will be a container manager for Kubernetes. We are not going to install Docker. So let's go ahead and run that. It will take a minute or so to finish. Okay, that's completed. On line 16, and then we need to start the service. And before doing that, we need to create a directory called containerd and the etc directory. So go ahead and run that on line 16. Then on line 17, we're going to be elevated to root. And then on line 18 is actually the command that will start the service. So let's go ahead and do that. And then we see the service has started. We'll exit the root command and we continue down. Now we're going to we are going to start installing Kubernetes. The first thing that we need to do is to get the GPG key and install it locally. So on line 22, that's what we do, and that is done. On line 25, we're going to actually now install the Kubernetes repository. So let's run that. And we need to confirm that to continue. Again, that will take a minute or so. And that's completed. On line 28, now we are going to install a new command line, CLI, kubeadm, kubelet, and kubectl. So let's go ahead and run those. Still going. Okay, that's completed now. On line 31, and now we need to make sure that the packets are allowed to travel from the bridge traffic. So what really means is that there are some CNI providers such as Flannel that use bridges to communicate between the pods that are on the same server. So we need to make sure that we enable this line. So we need to copy that and go to this file, sysstl.conf file. So let's open that, and we need to add this line at the end, again, to allow Linux nodes, iptables, to correctly see bridge traffic. So let's go ahead and go right at the end, and we're going to add that line there. Okay, and then on line 34, we're going to, again, elevate to the root for the next command. And the next command is we need to make sure that the packets that arrive at the node's network interface be forwarded to the pods. So what it means is if you have, say you have two pods, one on one server and one on the other server, if that pod wants to talk to the other, so it has to go, the traffic usually goes through the default network interface of the second server, but the packets arrive there. And then we need to make sure that those packets are forwarded to the destination iPod on that server. Otherwise, the packets, the traffic will be dropped. So we need to do that. So around 36, we run that command. That's done. We exit the root. Now we reload system control in order to the changes to take place, to take effect. On line 43 and 44, we need to install a couple of modules. One is for overlay networking and the other one is for netfilter. So let's go ahead and run those. And that's done. And one thing that you need to make sure is that add all the servers that that will be part of your cluster, you need to add them under the etc/hosts and add the server name and IP address. Unless you are using a dedicated DNS, you need to do that, otherwise the name will not be resolved. So, and the communication between the servers will not happen. So I already done that, just kind of reminder for you, if you're following this, just make sure to do that. Next, we need to disable swapping in the FS table. So let's go ahead and go into that table, nano there, and that is this line here, the last line, swap.image. We need to comment that out. Okay. And we need to do the same thing. We need to turn off swapping at the command line also, and that is on line 56. Okay. Line 59, we need to now download all the images that are required by Kubernetes. So those are the pods that are system pods that are needed. So I'm going to run that on line 59. It will take a few minutes. I'm going to pause here, and then we'll continue once that's completed. Okay, that's completed now. And then on line 64, that's where we're going to actually initialize the cluster. And this line, this section has to only be run on the master. So do not run this on the nodes, other nodes. Only run it on master. So let's go ahead and execute line 64. Again, that's going to take a little while. I'm going to pause, and then we'll continue once that's completed. So the cluster was successfully initiated. And then once it's done, it provides some instructions what to do next. I will walk through that up here. But one thing that you need to make sure is you need to copy this last one here, this command, qadm join, and then with that GUID and token, and you need to run that on your non-master nodes. So just make sure that you take note of it, just copy that, and because you need it later. So as part of the instruction that provided down here, we need to create a directory called kube. This is a hidden directory, and that will contain the connection string and the certificates required to connect to the Kubernetes. So let's go ahead and create that. That's created. Now we need to copy the certificate again and the connection line, this admin.conf that contains all the connection strings and the certificates needed to connect to Kubernetes. We need to copy that from the Kubernetes itself to this folder that we just created, and that will allow us to connect to Kubernetes from command line. So let's go ahead and do that. And lastly, we need to set the appropriate permissions so we'll have access to it. So let's done that. That's completed. Now next, we need to install a CNI provider on line 71. So I'm going to install Calico. So I'm going to download the YAML in line 71. Let's go ahead and do that. And that's done. I copied that file locally. Now I'm going to apply kubectl apply on line 73, kubectl apply -f, and the YAML file will just download it for Calico, and that will install Calico on our master. So let's go ahead and install that. That's completed. Now, the next thing that we need to do is we need to copy the entire kube folder that we just created up here with that configuration file in it, and then we copy it to the other server. So this is node, the other node, and that just makes it easier for us so we won't forget later on, because if we don't have the certificate, if we log into the server, we try to connect to Kubernetes from command line, we won't be able to do that. So let's just, and I'm just copying that, yes. That copied that. Okay, now we are done with the master. We need to just exit from there. And we need now to SSH into the node, one of the nodes, as many as node as you have. So you have to go and do this step on all other non-master nodes. So let's go ahead and connect to that. Let me just put my password. Okay, and then now the next step is we need to paste that command that I told you, kubeadm join. So we need to run that now on our non-master node. So we need first to run it as sudo. Let's put in my password. Okay, I'm going to now run that kube join, and that will join that server to the newly created cluster. So it's going to take a little while. I'm going to pause that and we'll continue. So it was successfully completed. It says this node has joined the cluster. So we have successfully joined, run the command. So I'm going to exit now as a root. So I'm on server 2. So let's just run some command, for instance, look at clusters. So this one is kind of testing our cluster. So let's do that. And as you can see, it gives us information about the newly created cluster. That's the IP address, that's the port number, and so on. So this is some information about the cluster. And then the next one on line 95, just show the nodes that we have for this cluster. So around that. And this is the command. So we have two nodes. One is server 1 and the other one Ubuntu server 2. And so one is master and the other one is just a regular node. So we are on the regular node. So just kind of test things out, on line 101, we're going to install, we'll deploy an image, a pod basically. So we're going to run that from Google itself. It's a Hello World application. It's a very simple application. And we can see that the deployment was successful. On line 104, we just get to kind of verify that deployment, and indeed, the Hello World application was created. We can just do something like, take a look at the pods, and you can see there's only a single pod created. And we can then do other things. For instance, on line 110, we can add one more. So right now we only have one pod for that service. We can scale it up to 2 pods, so we're going to run that. And again, we're just going to double check that. We run that. And as you can see now, we have 2 pods. So this is going to complete our session on how to set up Ubuntu server, installing Kubernetes on Ubuntu server without Docker runtime, and instead we installed containerd. Thank you very much for viewing this, and I hope you found it useful. If so, please give it a like and subscribe. That would give me motivation to create future topics. I also have other videos, and I'll provide a link in the description, so you might be interested to view those. Specifically, I talked about container networking and CNI and what they are, and I covered that great detail in this 3-part series. In part 1, I start off with before getting into container networking, I talk about what then kind of basics of networking, such as OSI model, and the routers and bridges and switches, what they are and what they do, and then we kind of graduate into a container, and then we set up things such as Ethernet and bridges in code. We create those. and then we link them together on one server, and then we kind of set a communication between two different servers, and we emulate and kind of overlay network. So that, and then in part 2, we'll talk about CNI, what Container Network Interface is in detail, and lots of graphics. And then we talk about Flannel CNI plugin, which is which is one of the popular ones, especially for smaller network Kubernetes environments. And then in part 3, in great detail, I cover Calico, which is arguably the most popular CNI provider, how it works. I also talk about some networking concepts such as BGP, Border Gateway Protocol, and IP protocol, and how they kind of fit into Calico, and how Calico leverages those, and how we can customize Calico if we don't want to use the default setup. So I hope you find this very useful, and thank you again, and hopefully we'll see you soon.